All right, today we will be going over cluster analysis in R. So you're gonna want to start out with that read Excel library, read Excel. Next, you're going to want to tell R where your data is. So we're not doing import, which is, bay right now, but we gotta get that side import, which is the actual location of the file in my computer machine with the read Excel, and push it into C data, which we will use not often, actually. It's totally not making sense to do this except for this section right here, but that's not important right now. It's 1106, so it's fine. Everything's fine. We're going to attach C data, which basically tells R that for the remainder of line 11, I want to call from this database. So when we open it back up and look at the different databases, I pretty much just want to use C data, which has the stuff that we want. But I'm only using it to not have to type in relationship satisfaction all the way and push that into REL, and not have to type in work balance all the way and push that into WLB, and not have to type in job satisfaction all the way and just push that into JS. There's these three, well, half of this line, and these other 4 lines didn't really need to do, but just makes my life easier. So next we're going to want to scale the 3 variables that we want to use because they're all on different scales. So we want to get the z-scores for the Euclidean distance, which is something that we'll be using to determine the number of clusters. So we'll make it into a whole separate data frame, so it makes it that my data right there. So we have the same number of observations, but only focusing on the 3 variables that we've scaled into z-scores. And it's kind of hard to tell the difference because we have so many variables there, but it's there. It's a thing that we did. Making z-scores for Euclidean distance, so it needs to be standardized, so that's what we did. We transformed it. Next, we're going to do library cluster, and so we're going to do 3 different ways of finding out how many clusters we have around these 3 variables, which, big surprise, 2 of these 3 were terrible. So we did the gap analysis, which was absolutely terrible. I kept getting 1. Where is it? It's right down here. So I kept getting 1 factor, and I used 3 different data sets and a bunch of different combinations of variables. So I don't know what happens in the gap analysis, but I hate it, and it's hard to do an assignment on clusters when you only have 1 cluster. So next we tried the scree plot, and ooh boy, ooh-wee. So that's what this second one does. Basically makes your scree plot, and it is just absolutely gross. Like, it could have like 4 or 6 or 10. Too many. Can't tell. It's hard. It's disgusting, and I hate it. So the actual good one is the nuclear option, which, if you see the highlighted green Euclidean up here, this is what we use the scaled scores for. Basically, we're going to do library Euclidean, library NB clust, and we're going to push all this stuff into NB, and we're basically going to take the data frame, my data, the standardized one that we made, and make the Euclidean distance calculations. And that's like, from what I understand, it's the distance between each one of the variables inside of the distance between each observation inside each of the variables. Pretty sure that's how that works. And basically it calculates the average distance, and it will determine factors that way. So the library facto extra in the fviz basically creates this neat little section down here. So this is the Euclidean distance stuff. So it gives us a bunch of indexes of Euclidean distance and some stuff that I don't really, they look like, I don't know what they look like. They look like weird shapes, but it's the number of clusters, and I don't really understand how they work. And we also get a neat little bar plot, which I do understand. Basically, here are the number of clusters and of the frequency of the indices. So the indices are basically judges staring at your data, and they're like, hey, I vote that there are 3 clusters. So how many judges voted for what number of clusters? So the most popular Dancing with the Star contestant of clusters was 3. So we went with 3 clusters for the remainder of our data. Yeah, so basically that's how many proposed, and that's how many of the best number of clusters we had. And it actually just tells you there. So numclust, we're going to push 3 into that. So 3 is the number of clusters that we have, and we're pushing that into numclust to use in our creation of a dendrogram. And a dendrogram basically takes all of your data and works it in a bottom-up analysis method. There we go. So there's all my data down there, and we tell it that we want 3 clusters, and so it starts pushing it together, making the clusters into these 3 groups. So here's 1 cluster, here's the second one, and here's the third one, and I wanted to make it red. I was going to make it blue, but Tan told me that she was making hers blue and yours was already green, so I was like, gotta stand out somehow. But basically, this area plots the dendrogram using the Ward-D hierarchical H cluster method, and pushes, or I'm sorry, it doesn't push anything. Well, pushes the results of that cluster into groups, the variable groups there that we will use later for validation. So it basically takes the clusters and actually sticks them into a usable variable of groups for us. And these other 2, D is used to determine the distance that we're using in the dendrogram. Fit is the method of creating the dendrogram, and then plotting it is actually creating it. I don't know if I went over that. And these are just how we want it to look. So next part is actually validating our clusters. I explained it more in the results and discussion hybrid document thingy, but basically I added age and tenure as 2 external variables. It is an external validation because these 2 variables were not in any of our 3 variables that we use to make our clusters. And you'll also see that groups appears here as well, because we're going to use that to run some ANOVAs and some chi-squared analyses. Yeah. So for the first one, we wanted to see if there was a difference in correspondence between clusters and age. So that is this first chi-square down here. And so we created the table of the 3 different clusters, and I have no idea what this sidebar is. Oh, this is the ages that they appear in the clusters. So there's like 1 person in groups 1 and 2 are 18, and then there's 6 people that in cluster 3 that are 18. And so we basically wanted to see if there were significant differences in the clusters pertaining to age, and our chi-square test was not significant. So there's just a cluster of, I was going to say clusterfuck. Yeah, there's a clusterfuck of different ages in each of the 3 clusters. Moving on, we wanted to externally validate to see, or we wanted to use external validation to see if the clusters corresponded with tenure. So our research question was basically, is there a group of people in our organization that we can determine are more likely to attrit? And if so, how do we identify them, which is what the clusters would be, in order to provide an intervention that keeps people in the program because attrition is expensive, blah, blah, blah. So because I had 3 clusters, I can't just run a t-test. I have to run an ANOVA. And so that's what this is up here. This is the ANOVA that I had to run, and the summary of the ANOVA, which basically gives me the ANOVA table to determine whether or not the ANOVA is statistically significant. It was not, which basically means I could have stopped here because, hey, there's 3 clusters, but none of the clusters differ significantly in their correspondence with tenure. So there's no cluster that you can single out and be like, hey, please don't quit. We'll give you a raise or something. So because of that, I could have stopped there, but just for the sake of knowledge, I guess, and learning how to do this and doing it later, I ran individual ANOVAs for each of the 3 variables in relation to the group and got those to see basically if any of the variables were statistically significantly different within the clusters. So the relationship satisfaction, the work-life balance, and the job satisfaction. I think 2 of them were. So relationship satisfaction was statistically significantly different. Work-life balance was, and job satisfaction was, but none of them, it doesn't really matter because the original ANOVA of group versus, not group versus, but group with tenure was not statistically significant. So that's pretty much it. Also, we have box plots. Forgot to show those. There's box plots, which basically help us visualize each of the, not visualize each of the ANOVAs, but visualize the differences between the variables and the clusters that the variables are in. So for example, for relationship satisfaction, we have our 3 clusters down here, and each of them has a different mean relationship satisfaction level. So group 2 has the highest, but for work-life balance, group 2 and group 3 are tied for the highest work-life balance. And group 1 and 3 are the highest for job satisfaction. So that is how you cluster some analyses. I think I'm done. Bye.